Welcome to polynomial functions. And as we work with polynomial functions, we've been working, a polynomial function just means a function that has more than one term. And in this case, and not in this case, slash reflecting, we have worked with these functions all along. We worked with something that is x squared, f of x equals x squared plus 2x plus 1. And that is a polynomial function. We've referred to it as a quadratic function, but it's still a polynomial function. So we've actually been working with polynomial functions all the time, for a while, and we know that this quadratic equation is actually shaped like a parabola, and it is opening upward. And we'll learn in this section what that opening upward and the end behavior, what we're talking about. So when we look at classifying polynomials, we classify them by their number of terms and their degree. And the number of terms in a polynomial, if we look up here, here's some examples. The number of terms in a polynomial are separated by addition and subtraction signs. So in this case, this p of x equals this thing right here actually has 4 terms. And it has a cubic term to the exponent of 3. It has a quadratic term to the exponent of 2. It's a linear term because your x is to the value of 1. And a constant term because, well, we don't see a variable. Or if you really want to think big math, it's a variable to the degree of 0. But that might be a little bit too much diving into right now, so we will simply remove that. So those are some of the examples of terms. Again, terms are separated by addition and subtraction. So looking at example A, write each term, or I'm sorry, this first set of examples, write each polynomial in standard form, classify and identify the number of terms. Well, we should remember that the standard form of a polynomial, standard form of a quadratic equation, the standard form is when we have descending numerical order of our variable degrees. So we would reorder this. Example A, we have 3x to the third minus x plus 5x to the fourth. Well, this fourth is going to be my highest degree variable, so that would be my leading term. So I would have 5x to the fourth plus 3x cubed minus x, and of course we know that that x is to the first. Now, I could have combined like terms, but in this case there were none to combine, or I should have, but there were none. So then I have 1, 2, 3 terms here, so that gives me a trinomial. And then it is called a quartic trinomial because quartic is for the fourth degree there of 5x to the fourth. Looking at B, of course, we do have some terms that can be combined. We have a 3 and a 10. So when I'm reordering this in standard form, I make sure to combine like terms. So I end up with a negative 4x to the fifth plus 2x squared plus 13. And that again is, there's 3 terms there, so I do have a trinomial. And because it is to the 5th power, that is known as quintic. And so there you go. Going to this next step, we talk about describing its end behavior of a polynomial function. And we know that you should remember that when we have a function, that when we had a quadratic equation and it was x squared, of course, we knew that it opened up that way because my a was positive. And when the a was negative, it opened up this way, opened downward. And so some of these things we already knew. When we had a cubic function and it was positive, we knew that its general shape looked something like that. And when it was negative, it did the opposite. It was flipped over the x-axis. Now, so if you notice, we have So as we look at these functions, I do have this x squared. My a value is positive, and I have a in behavior of up, up. So we are talking about what is going on, the directions of the graph to the far left and to the far right. So as this function goes to the far left, it is going upward. As this function goes to the far right, it is going upward. And as the x cubed, its in behavior is going to be down, up, because as we go to the far left or negative, the function continues going downward along the coordinate plane, and then as we go to the right, the function is going upward in a positive direction. And we can see here that the quadratic, or the quartic function has a up, up stance, and then the quintic in behavior has a down, up in behavior. And then as we have a negative a value, looking to the negatives here, we see that we have the parabola opening downward, down, down, and then we have the cubic function opening up, down, and then we have the x to the fourth, the quartic, opening down, down, and then the x to the fifth is going up, down. And what we can see here is, looking at this, looking at ax to the n being the exponent or the degree of your variable. When a is positive and n is even, it's a 2, it's a 4, then it is going to be up, up. We can see that. Up, up, we can see that. When n is negative, it's going to be down, down. Come over here. It's going down, down. And then when n is odd, that would be our 3 and 5. 3 and 5 are odd numbers, and a is positive. It is going to be going down, up, down, up. And then when a is negative, it is going to be going up, down, up, down. And that is the in behavior based on your leading term of an equation. So if we come over here and we look at this example, and it says, consider the leading term, what is the in behavior of the graph? Well, the leading term is going to be negative 4x cubed. And given that, what is the in behavior of the graph? Well, judging by the negative a, and we have a negative a, and it is a odd exponent because it is 3, the in behavior should be up and down. So it should be something like that. And if we look at the graph, I stole that little picture out of the book, we can see that yes, it is up, down. And if we notice a turning point, we seem to have a turning point right about here. And let's see. And another turning point right there, which is actually pretty hard to see. But again, the turning point are the places where the graph changes direction. Let's see, what else do we need to know? Gosh, it is, well, that's it. That's all the example's asking us for. So let's just go on to the next example. And it reads, it wants us to go ahead and what is the graph of each cubic function? Describe the graph in behavior, the turning points increasing and decreasing. So if we were to graph that, that is going to be a cubic. It is going to have 4 terms. It's 4 terms. It's cubic. It is opening in behavior because it is going to be a is negative and it is an odd number. It is going to be an up, down in behavior. All right, that's going to be the general shape of my graph. I was able to find a y-intercept. So I know I have 0, -2, or let me change that, sorry. No, that should be right. Let's see here. We have in behavior again, which is going to be up, down. And we looking at this, where is it increasing and decreasing? Where is its turning points? Well, if you go to the calculator and you look for some of these values, this value right here would be a minimum. This value right here would be a maximum. And you plug that into the calculator, you're going to find out that those turning points are, the turning points are going to be 0.33 or 1/3 and negative 2.15, and then 1 comma negative 2 are going to be my turning points. Okay, and looking at increasing and decreasing, which we haven't necessarily talked about that, but it's something that we've discussed in algebra, is when I'm talking about increasing, I'm looking at the slope of my graph is increasing. So I'm increasing here because the slope of my function is increasing, and I'm decreasing here because the slope of my function is decreasing. So I know that I have these values right here and here, which I'm not increasing or decreasing. Therefore, my intervals are, therefore my function is decreasing from negative infinity to 1/3 to this point right here, and again from 1 to positive infinity, and then it is increasing from this 1/3 value right here to up to 1, and that would be my increasing and decreasing intervals.